Human biomechanics. The fastest served tennis ball served by Big Bill Tilden in 1931 was measured at 73.14 meters per second. The mass of a tennis ball is 57 grams, and the ball, which starts from rest, is typically in contact with the tennis racket for 30 milliseconds. Assuming constant acceleration, Part A. What force did Big Bill's tennis racket exert on the ball if he hit it essentially horizontally? Part B. Draw free body diagrams of the ball during the serve and just after it moved free of the racket. Okay, so let's note that we have a constant acceleration. So that implies with initial velocity 0 meters per second, acceleration is delta v divided by delta t, and we start from 0 and the target speed is 73.14 meters per second minus 0, and the process takes 30 milliseconds, so 30 times 10 to minus 3 seconds, so this gives us 2438 meters per second square. Okay, so we can calculate what force corresponds to this acceleration. So F is going to be mass times acceleration. This is the only horizontal force, so it is the net force. This is mass is 57 grams, so 57 times 10 to minus 3 kilograms. Acceleration is 2438, so we find 139 newtons. So if I look at the problem statement, I see that the minimum number of significant figures is here in the mass of the tennis ball. So I have to reduce this to two significant figures. So this is 140 newtons when we round it to two significant figures. Okay, part B. We want to know the free body diagram during the serve and just after the serve. So free body diagram during the serve. The tennis ball has its weight, mass of the tennis ball times g, and it's not touching the ground, right? So when we hit it with the racket, it's free of the ground, and therefore it only feels a horizontal force F that we apply, and there is no because there is no physical contact with anything else, it basically feels the force F from the tennis racket and its own weight, and that will be it. And free body diagram just after the serve. Now the tennis ball is even free of the racket. The contact has been lost. So this is after 30 milliseconds. What happens to the tennis ball? Well, it just feels the weight. So it is going to be the gravitational force, mass of the ball times g. So that will be it. Okay, so to summarize, we have the record in the fastest served tennis ball, 73.14 meters per second, achieved by Big Bill in 1931. Given the mass of the racket and the physical contact time between the tennis racket and the tennis ball is 30 milliseconds. Assuming constant acceleration, we can calculate what force was applied to the tennis ball. So with constant acceleration motion, the average acceleration is equal to instantaneous acceleration, delta v over delta t. So starting from rest, we reach 73.14 meters per second in 30 milliseconds. So we obtain the acceleration. F equals ma. So mass at 57 times 10 to minus 3 kilograms times the acceleration gives us 139 newtons. But then I carefully examine the problem statement. 4 significant figures, 2 significant figures, 3 significant figures. This should be reduced to 2 significant figures. So it is 140 newtons. That should be the way I report the answer. Now the free body diagram during the serve and just after it moved free of the racket. During the serve, we have the force F that we apply horizontally. So it was mentioned that it is essentially horizontal. And we have the weight of the ball. The ball is not touching the ground, therefore there is no other normal force or anything like this. And just after the serve, we are even free of the racket, so this force disappears in 30 milliseconds and we just feel the weight of the ball.